This Week in Virology, the podcast about viruses, the kind that make you sick. From Microbe TV, this is TWiV, This Week in Virology, episode 545, recorded on April 26th, 2019. I'm Vincent Racaniello, and you are listening to the podcast all about viruses. Joining me today here in New York City, Dickson Despommier.
Hello there, Vincent.
How are you doing?
Doing good. Just finished my last class at Fordham.
It's done?
It's finished.
Are you finished?
No.
Is it raining out?
Yes.
But is it warm or
it's
chilly?
Thundering and lightning.
Oh, neat.
Yeah.
Also joining us from Western Massachusetts, Alan Dove.
Good to be here. It's rainy, 52 Fahrenheit, 11 Celsius, and overcast. No thunder, though.
Ah.
And from Madison, New Jersey, Brianne Barker.
Hi, everybody. It's about the same here, 56 Fahrenheit and 13 Celsius, and also very rainy. I've been hiding in my office all day to avoid that rain.
No thunder?
I haven't heard any thunder thus far, no.
Okay.
Are your courses done?
Monday is the last day of classes, and then we have exams.
We have till the following Monday.
Okay.
My last class is Monday, what is it, May 3rd? Something like that?
Yeah, I think that's it.
That is next week. So.
All right, we have a guest today. He's returning, I don't know, more than 3 times.
You must like it here.
From the Integrated Research Facility at Fort Detrick, Jens Kuhn. Welcome back, Jens.
Hi, everybody.
Hello, Jens.
My weather is as crappy as yours. So, rain and 22°C.
Right.
You're not too far from us. But is it warmer there, no? 22°C.
Yeah, I mean, it's nice. Temperature-wise, it's nice, but it's gray and cloudy and raining.
Yeah.
Now, we just spent a lot of time trying to get Jens on the Skype. It's difficult. Every time we do this, it's a problem.
Keep reinventing themselves.
And next time we say we'll do it this way, but then I forget what I said. I should write it down. But he's here. He's on his phone. Sadly, he's holding his phone up to his ear. I'm really sorry about that.
It's okay.
But,
we'll
live. Old school.
Now, you're here to resume what we talked about on TWiV 508, where, the name of that episode was Bioweapon. And if I remember, we talked about your experience going to visit, was it Vector or Biopreparate? Vector, right?
Yeah, Vector.
We talked a little bit about the Soviet program of bioweapons, right? What else did we talk about, Jens? You just listened to the episode, I understand.
Vector sounds a little bit like Spectre, which comes from a James Bond movie. And
yeah, it did.
We went very broadly through the history of bioweapons programs, how it started in ancient times, and how they developed into classical programs and then into modern molecular programs. We talked a little bit about the individual norms against biological weapons, starting from like old Brahmin laws to the Geneva Convention of 25 to the Biological Weapons and Toxin Convention later on. And then about the Soviet program being the biggest program that we know about, and how it was done completely clandestinely and illicitly against the convention over years. And then my time over there trying to help transform one of those bioweapons facilities into a peaceful facility within international grant assistance programs.
That was Serratia Marcescens, wasn't it? The subway program, the clandestine...
In the U.S.?
Well, that was the U.S., yeah. So the U.S. had similar programs, but the U.S. programs were all, in the 50s and 60s and so on, and they stopped in 69. The Biological Weapons and Toxin Convention was 72, with different countries joining the convention by ratification in different years after that. And the Soviet Union ratified that document, but then continued developing biological weapons until 1990s, early 1990s.
Until there was no Soviet Union left.
That's right.
Now, the Serratia was released over the Bay Area, right?
I thought it was here in New York.
In the subway in New York, I was just reading the book by Seth Karras, and he says they released a bacillus strain in the subway to see how it would spread.
See how it would spread.
Right. And it said the Army, who did that clandestinely, said it would have infected about 10,000 people if it were Bacillus anthracis. Nice experiment.
Wow.
There were a bunch of these experiments without any kind of review board or any kind of consent.
Right.
Also over several islands where spores were released to see how far they would travel under different meteorological conditions and so on. It was not only the U.S. Canada did a lot of that as well, and other countries as well.
It's interesting some of the results those projected. 10,000 people infected, but then if you look at actual incidents when bioweapons have been used, the results have not been nearly as dramatic in most cases.
Right. I think this has a lot to do with mathematical modeling versus real world. Number one. So what you do, or how these experiments were done in the past, is typically if you look at the Russian program or the UK programs, they would use sheep. They would bind the sheep to a particular wooden pole in a radius from each other, and then they would release something in the air and then see whether you can find that particular bacterium in the nasal swabs of the sheep. Or you do it even simpler. You have agar plates at different places, and then you see whether something grows or not. And of course, none of this is actually a real good measure whether infection actually takes place and the disease actually develops. So I think that is one part of that story. And the other part is I am not really aware of biological weapons programs, developed weapons being used. So there are incidences of biocrimes and bioterrorism, so small-scale events. You can look at the Amerithrax attacks with the envelopes full of spores and so on. But those were dispersal devices that were not really dispersal devices, right? The biggest problem with the anthrax letters, of course, was the distribution machine in the postal office, because that created aerosols and the spores went everywhere. But that was not planned in by the perpetrators.
Right. I think the only real test of this that comes close to the simulations would be the Sverdlovsk incident, right? Right.
Yes. And so which
did kill a bunch of people, but nowhere near 10,000 as far as we know.
Right. But so there are two things that are important. Number one, of course, what went into the air in all likelihood in this instance was an actual weaponized preparation of something, right? So this was a virulent strain. Number one, it was probably highly pure, it was probably highly concentrated, and so on. And then it was, I think it was a science publication on all of this by Matthew Messelson at the time, where they have this, there's a really interesting picture where they show the cluster of cases of anthrax in relation to the release point and in relation to the wind at the time, and in relation to the villages where they are. And so, of course, it is dependent on what your population is like, at which time point you're releasing these spores, because if everybody's indoor, then, of course, you're going to hit much less people than if you have them under the air and so on. And so I think all of these factors are a reason why this is, even if you have a quote-unquote very good bioweapon with a very good agent, it's not easy to cause mass casualties, because it's unpredictable what the oxygen content and UV light and wind and so on will do to the dispersal of your weapon.
Right. The big thing that I've taken away from reading about biodefense and bioweapons and biowarfare and so forth is that these weapons really suck. Right. I mean, as weapons, they're just you can put huge amounts of money and effort into making them, and then you release them, and of course, it's a natural agent, and you've got all the problems of trying to get a natural agent to survive out in the environment, and it you'd be better off investing the money in explosives, right?
Well, I don't want to advocate for any kind of form of terror.
Well, no, but I mean, if you were a terrorist group and you wanted to be efficient, this seems like a very poor choice.
Right. So I think the problem with all of these discussions, we brushed on this a little bit last time when we discussed bioweapons in general, is intent. The question is always what does a particular perpetrator plan to achieve. So I think I mentioned last time that the one Ebola case that we had in Texas caused a huge uproar, massive economic impact and cost. So if you just want to disturb society, you don't you don't need your weapon necessarily to be very effective. And so that's where education comes in, right? And the moment the population is educated about a particular agent and they would know that they shouldn't freak out over Ebola virus in one particular case somewhere in a hospital, there wouldn't be any economic impact, and therefore that would go away. So biodefense doesn't necessarily have to be research on a particular agent in a science lab. It could also be something like public outreach and education. Vice versa, if you look at the Soviet doctrine, we are not absolutely sure what the overall goal of this program really was. So militaries, of course, always want to develop all different kind of weapons for all different kind of situations. But typically, especially large programs, they fall under a particular doctrine on destruction of the enemy under particular circumstances. So they're tactical and strategic considerations. And one of those strategic considerations that pops up when you look in the Soviet program was that there was a nuclear exchange first. And then basically to finish off the remainder population, you would use biological weapons, because at that very moment, everybody is immunosuppressed and so on. And then you don't have to worry about your agent even losing a little bit of virulence. It might do that job, right? So that is a thinking that I think hopefully is not around anymore, and it doesn't really apply to anything anymore. But if you think about Cold War thinking, that kind of perfectly makes sense, because everybody was thinking about complete destruction of everybody.
Made a bizarre kind of logic, yes.
Yes, in a bizarre kind of logic, that's right.
So I want to refer the listeners to a working paper called Bioterrorism and Biocrimes by Seth Karras, and it's a free download. We'll have a link in the show notes. In fact, after our last episode, Jens, he emailed and said that was a nice discussion on TWiV. He was listening, which is
I was very happy about it too.
And he states at the onset, there's been an explosion in interest in bioterrorism by criminals. Most of the events have happened in the 90s, and he goes through each one of them. It's quite interesting. And there was one I wanted to tell Dickson about. A graduate student in parasitology took Ascaris sum eggs.
Yeah, I'm totally aware of that.
And used them against his roommates, but they don't infect people, right?
Well, they do, but they don't complete the life cycle, but they still cause pathology when they migrate. Mm-hmm. So it was the only Ascaris he could get a hold of, basically. And he put it in the oatmeal, not in the opium. He put it in the oatmeal. So it was at McGill, I think.
Most of the interest here are pathogens and toxins, mostly bacteria. He says few perpetrators have considered viral agents. HIV appears in 15 cases and in 4 of those murder cases, but not other viruses.
What about the blankets with rabies in the 1700s?
Well, that was smallpox usually, wasn't it?
Yeah, pox. I'm sorry, pox.
Well, yeah, but that would not fall under biocrime, right? So last time when we discussed this, we differentiated between biocrime, bioterrorism, and biowarfare based on intent. With biocrime being something like revenge or financial interest and so on, bioterrorism trying to within a country change political outcome or bring religious beliefs to somebody, and then biowarfare being basically nation state against nation state. And of course, there are gray zones in between those 3 different categories. But if you imagine somebody saying like, I'm HIV positive, here's my blood in the syringe, and you better give me your money or else I stick you with the syringe, that's a biocrime. Yep. That's not a bioterrorism thing. But if you look at the smallpox blanket thing, that was to overthrow an area, and so of course that is not biocrime.
So in this paper, there's a table which gives some numbers. If you attacked a city of 1 million people, how many people would be at risk and how many deaths would there be? And, the most lethal would be anthrax, 180,000 people at risk, 95,000 deaths. And the only virus on this table is Venezuelan equine encephalitis, where there'd be 60,000 people at risk and only 200 deaths. So, viruses.
But again, these are the kinds of projections that in the real world, the numbers are likely to be much smaller.
Yes. So I don't know.
And of course, many of these projections also come, of course, from understanding of experiments that were done, several decades ago. Mm-hmm. So Venezuelan equine encephalitis virus was a main component of most offensive bioweapons programs in the 60s.
So yesterday I had office hours, and one of my undergraduate virology students, she said she just is in terror that someone is going to walk into New York infected with smallpox or Ebola virus as a bioterrorism event. And I said, well, I think it's unlikely because it's not a very efficient way to kill people. And I guess maybe you don't need to have a lot of deaths to terrorize, but we haven't seen that.
Well, I think to Jens's point, it being about goals, the Amerithrax attack is actually a really good illustration of that. It killed and actually even infected very few people, but it completely refigured billions of dollars in defense spending and had a huge public and political impact.
Yeah, I suppose.
Yeah, and even before that, if you just look at the cost for remediation of the sites where the spores were brought out, it's millions and millions of dollars.
Yeah.
Yeah.
So do you, Jens, is it likely that someday someone will use a virus in some kind of bioterrorist act? Who knows, right?
Like rabies.
I don't. Yeah, it's likely. What do you mean with likely? Which percentage points do you want to give them? Right. So there's definitely no doubt in my mind that people will consider it. And that some people will try it because people are not. I mean, people try everything. The question is, how successful will they be when they try it? And the reason why viruses were not high on the list, of course, is, as we all know, viruses are finicky. So they're not easy to deal with, let alone are they easy to manipulate with. So this notion of somebody going home and then, I don't know, somehow acquiring Ebola virus and then manipulating it to make it more virulent and all this other stuff. Every
without
virologist
killing themselves
knows. That's right, and without killing themselves. Every virologist knows this is not going to happen, right? So I mean, we have been trying for I don't know how long to just get a GFP gene into negative sense RNA viruses and keep the viruses virulent at the same time, right? And with the exception of one or two viruses out there, we have been very unsuccessful with it. So I think in the end, if somebody wants to do something bioterroristic, bacteria will be the choice for now because they are relatively easy to acquire and to grow. But then of course, you have antibiotics against all of this, and I'm not really sure how big of an event that then would be. And of course, we have vaccines against many as well. So it is the larger question here. So I am personally, and I said this last time, I'm not an arms control specialist. So and of course I don't know what kind of secret agencies have which kind of information about what. I'm personally not really concerned about biocrimes. They will happen, of course, as every crime happens. And I think I said last time I don't see a big difference between me being killed with a syringe full of a virus or me being killed by a gun. I'm dead, so that's both sucks. So
you suffer more with one than the other.
Yeah, depends on how you are being shot.
Maybe
right?
it depends on where you're shot.
Yeah, so I think even that argument of like the suffering time and the bacteria being so much more immoral than some other weapon, I'm not really sure how much I buy into all of this. But the large concern, of course, is the national security concern. So can a perpetrator actually bring a country to its knees? And so that is an unlikely event, but one should be prepared for this if somebody would try, right? So if you think nation state against nation state, and if you think Cold War and how much effort was put into developing nuclear weapons so we can kill the entire world 20-fold over, shows you that crazy is not necessarily unlikely.
Well,
so that worries me.
One thing that often comes up when I have that same conversation that Vincent mentioned with his student. I also will have students come in from time to time who are very worried about the person with smallpox or the person with Ebola or what have you, is that we wonder about whether or not that type of sort of terrorism would be particularly effective because of how it could be directed. How do you prevent your mom from getting sick?
Right.
In delivering any of those
you got to immunize her first. She gets the
vaccine. The risk of blowback from a biological weapon is immense.
Right, exactly.
And that, of course, was one of the reasons why the Soviet Union probably invested a lot into bioweapons, because they were not worried about this, because there were huge distances between the target country and themselves.
You'll never find an anti-vaxxer doing this, because you've got to have a vaccine to protect yourself.
So yeah, and of course that is one of those blurry lines between offensive and defensive
that's happened
research, right?
Yeah, it happened with mustard gas during the First World War. A lot of the perpetrators of those events actually got gassed themselves when the wind changed. So
right.
Mm-hmm.
Right. And so if you look at the Soviet program, there were immense biodefense programs that you, on first face value, you could call legitimate biodefense because vaccine development and novel antibiotics and so on. But of course, they were developed under the backdrop of we are developing something that we need to defend ourselves.
Yeah, exactly.
Right.
Yeah.
So next month we will begin spreading the word about the biannual conference of the Defense Threat Reduction Agency's Chemical and Biological Technologies Department. And so they have a conference every other year, and we advertised it last time. So there's obviously governmental interest in this. People are thinking about being prepared, even no matter what people may think about the likelihood of this happening. And that's good. So you want to be prepared in ways. You want to discuss what could happen. And have you ever been to those meetings, Jens? I assume not, right?
I haven't been to the DITRA meetings, no. But of course, there's many other so they used to be ASM Biodefense, right?
Right.
It's now recalled. I forgot what the new name is. That was also very heavily focused on detection methods and new assays and so on. And of course, there's an overlap, right? A synergistic overlap between public health and biodefense ultimately. So everything that we learn from a biodefense perspective about Ebola virus, of course, is applicable for public health and vice versa. So I find the discussion of so much money being diverted from public health into biodefense a little bit disingenuous. Yeah. That said, of course,
at the same time, a lot of the expenditures for biodefense are things that will, it's nice to know how to prevent Ebola virus, but that's not going to prevent flu virus.
Correct. So there's something to be said, and the discussion can be had about what is an adequate percentage of a particular budget that should go into particular areas. And so when we get to the point where we withdraw massive amounts of money from malaria research so we can focus an agent that only 3 people ever gotten in history, yes, there's a discussion to be had whether that is in any kind of way justified or not. But what I don't like is these all or nothing discussions. So we don't need any biodefense because nobody will ever use these weapons anyways, and it's unlikely. So therefore, let's not do it at all and invest everything into cancer from now on. So I think this is it's a little bit ill-informed on. Yeah,
I think there's a whole zone in there that's if I could borrow a term, dual use, that would be biodefense related research that is going to have or is very likely to have public health applications as well, and that would be all the focus on dealing with mass casualty events in general, or dealing with diagnostic tools and that kind of thing.
Hospital capacity.
I like that
hospital capacity.
You turned dual use around. That was actually very nice.
I'm taking the term back.
Right.
Yeah, you're taking the term back. That was very clever. I like that. So maybe we should talk about dual use actually.
Yeah. So actually, we do have an agenda. We're going to talk. Let's talk about select agents, priority pathogens, Australia list pathogens, risk group. Okay, and then biosafety versus biosecurity versus biosurety. And then if we have time, we'll talk about dual use and gain of function, as Jens says, from a political point of view, which we haven't considered here on TWiV, right?
Right.
Sound like a plan?
Well, at least as far as I'm aware.
It's a plan. Can I just interject something for another show? And that is that there's an ecology to a lot of these diseases, and some of them are vector-borne, as Jen just mentioned for malaria, but we've had introductions in this country of mosquito species, which are either better vectors or not better vectors than the diseases that we were afraid they would transmit. And West Nile is one of those things that were introduced after the mosquito was introduced. So why aren't we paying attention more to bioinvasion from the outside than we are for these things? So, because they're preventable. We should, of course we should. And I did attend
emerging infectious disease is a grant category.
Yeah. No, I got it. But
it's a class. I taught it yesterday.
There you go.
I was
me too. Mine was Wednesday.
Okay, wait a minute. I was part of a discussion group from the Institute of Medicine in Washington, D.C., and they said this is the only gathering of the Institute of Medicine that did not have a recorder. because it was all about bioinvasion. Every bit of it was about that. This was just after the first wave of West Nile virus hit, because there would be lots of those things, right? And there were people from all walks of life, people from the shipping industry, people from medical entomology, of course they were there, and ecologists were there as well. And to the best of my memory, almost none of them had ever talked to each other before.
Mm-hmm.
Yeah, it's definitely it's a huge problem, and of course it overlaps with ultimately with bioterrorism as well, right? Yeah. So the old term biosecurity is actually an agricultural term.
Jens, you don't have to engineer the virus if you can get it into a mosquito, and the mosquito can then transmit it for you.
And if you look into the old programs, the U.S. programs and others in the 50s and 60s, they considered, and not only considered, the Japanese actually have done it, spreading actual insects. So they would fill their I don't know whether you can call them bomblets or not, but they filled them with infected vectors and then spread the vectors.
Exactly.
So plague in I think Manchuria or wherever it was, was spread that way, right? But this is a good segue into the term biosecurity a little bit, because biosecurity now, when people talk about is mainly related about the workers who are doing something and the facilities and how secure they are and so on. But if you go 20, 30 years back, biosecurity was a purely agricultural term that was used to describe protection measures of farms and factory farms and agricultural sites from pests from the outside, and not from a deliberate.
It's a bit confusing because it is still used in that context in agricultural safety and in food safety. People talk about biosecurity in those terms, and then you turn around and on the biodefense side, there's this other interpretation of the term.
Yeah.
Correct.
So what's the difference between biosafety, biosecurity, and biosurety?
Okay, so let's go through those three things, right? So biosafety is broadly said the protection of the laboratory worker. Mm-hmm. So we want to make sure that when we work with something, we don't infect ourselves or each other, or we don't bring anything home to our loved ones and so on. And the biosafety is, so in the U.S. we have 4 levels of biosafety level 1, 2, and 3, and 4. And those levels, by law, demand certain safety measures to be in place in order for you to be allowed to work in that space. So BSL 1 is the lowest one. That's typically the thing that you will find in high school when you grow some kind of an agrobacterium or something on an agroplate. The bacterium is known not to infect humans. It will not cause any disease. Nothing can, at least theoretically, nothing can go wrong.
Go wrong.
That's right. So the students will probably be advised to wear lab coats and goggles and so on, but probably not really for their protection, but more for creating good habits if you work in a laboratory, because they're not really working with something dangerous, right? And then you go up to BSL2, and BSL2 is the typical setting that I think most of us are used to working in. So you have a specialized room. You are you have to wear a lab coat. You have to have your goggles with you for particular things. You typically wear gloves. You are aware of your environment, that there are things that could infect you. So of course you have your microchem around and your ethanol and you spray stuff and you wash your hands and so on. You don't eat in the lab. You don't mouth pipette. So this whole spiel.
Hey Jens, is there proper dress in that? Like, are you not supposed to wear shorts and open-toed sandals as well? Because
yes,
because here we have a biosafety committee, right, which regulates all this stuff, and they say to me they cannot enforce people not wearing shorts and sandals in the summer, because I always say, these people are walking around and this is dangerous. You spill some hydrochloric acid on your toes, man, you're toast. And he said,
toast.
You're toast. We cannot enforce it. So is that true?
Really? We enforce that very much here.
I don't know why.
Yeah,
there's an overlap here between the biosafety rules and just workplace safety OSHA rules. Mm-hmm. And okay, thinking back to my time in the lab, Jens just listed a whole long series of things that I did routinely that you're not supposed to be doing. But yeah, you could enforce the workplace safety rules and say, look, this is a laboratory. You have to wear closed-toed shoes. Alan go home and put on something more appropriate?
I've never worked in a lab where I could go into with shorts and sandals. Not ever in my career.
I see it all the time here, and it bothers me. It's mostly summer students who come for the summer, right? And their PIs do not enforce proper workplace habits. Right. I think it's horrible.
I agree.
And
but I think that's something different, right? So it's the PIs not enforcing it is different from it cannot be enforced.
Well, I've talked to the head of the Biosafety Committee, and he told me that they cannot enforce it. They can only recommend it. I don't know why.
They may not. Okay. They may not be able to enforce it on the Biosafety Committee, but I bet if you, Columbia must have an office of worker safety or something. Your HR people would be able to put you in touch with them who could enforce that. You'll be very unpopular for doing so, but I'm pretty sure those.
Well, we can use TWiV as a medium to many people, right? Wearing open shoes and shorts is really stupid.
Correct.
In a laboratory.
It's really stupid, yeah. And so if you're a PI and you let that happen, you're stupid. I think you're asking for trouble, because if someone gets hurt, you're going to be in big trouble. If somebody spills hydrochloric acid. How do you enforce it at Drew, Brianne?
Mostly we enforce it with our students in the teaching labs, and that we send them home if they're not dressed correctly. We keep spare lab coats around, but it's really a matter of sending students home or not letting them participate in lab. Before I taught at Drew, my first day as a professor, I had a student walk into class with open-toed shoes, and I got to feel very professional in sending her home to get some closed-toed shoes. And she came back, and we were doing a microscopy lab, and she ended up spilling an entire bottle of microscopy stain on her foot. It happened to be that same student. It dyed the floor tiles forever. And so then I used to always show everyone the floor tiles when I talked about closed-toed shoes after that.
Good. All right.
Yeah, and of course this is an evolving thing, right? So, if you talk to older scientists, they all mouth pipetted in the days.
Yes.
And so
on. Bet.
And it has changed over time, of course, because things happened. There are statistics out there on laboratory-acquired infections and accidents.
So Vincent, how does acrylamide taste?
It's got an interesting...
A little like chicken.
I can tell you how DMSO tastes. But Jordi Casals famously was pipetting Lassa virus at Yale. And he got infected.
No, he was injecting it intrathecally. Sorry.
No,
Jordi Casals.
It's Jordi, not Jordi.
And he was working with Lassa, right? And the needle slipped off the head of the mouse and got him in.
Well, somebody was mouth pipetting in his lab, because it's in the book.
Yeah, because the other guy died from it. That was his technician that died from it.
Okay. All right, so that's biosafety. We're familiar with that. Keeping the workplace laboratory safe. And that can go from BSL 1 to 4, right?
Right, and so it's going up from that, and so BSL 3 and BSL 4, the safety measures just get ever more stringent because the consequences of an accident are ever more severe. Right, so the BSL 4 lab is typically that's the highest level. That's the one where people wear full body. You're not supposed to say spacesuits, but everybody knows what I mean when I say so spacesuits. Full body suits. That's right, and you're hooked up to an air supply and so on, and the suit is under positive pressure, so even if you have a little of hole, nothing can go in because the air squeezes it all out. And then with that come, of course, all different kind of standard operating procedures on how you do something. So, for example, you cannot easily introduce any kind of glass, sharps, corners, anything like that into the laboratory. So that means that the higher the biosafety level, the more safe you theoretically are, but also the higher the risk if something goes wrong, because the agents that you're working with have dire consequences. And also everything that you do gets slower and more complicated. Because you can, for example, not simply buy the most novel microscope and bring it in there, because you need to consider that it might have sharps, and then somebody needs to call mechanics to smoothen all the edges because you don't want to rip your suit and expose yourself to agents. Then there's the problem that if you want to ever bring it out of the laboratory, you need to be able to decontaminate it in some kind of a way. And most of the decontamination measures that you take in these laboratories are rather harsh, right? You might use formalin gas, and then you need to neutralize it. And finicky microscopes and other machinery don't necessarily like that. And so if you spend a few $100,000 on a microscope, you want to probably keep it longer than 3 months until the next decon cycle. And so there's a lot of these kind of things to consider. And so an awareness of the different biosafety levels, if you actually understand what it means, will also tell you why progress on certain agents is faster than on others, independent on how many laboratories there are, even in terms of having these safety levels.
Right.
So, and then the higher you go, safety also begins to overlap with security. And so that's the other term here that we want to discuss, biosecurity versus biosafety, right? So biosecurity...
I'm sorry, can I just interrupt just for a moment? The best training I ever had in this area was at the University of Notre Dame working with germ-free animals. Mm-hmm. And to make sure that isolator remained germ-free required heroic efforts to get things in and out of it. You had to have a chamber where you used an acid, which kills virtually everything, but then it dissipates. And then you can reach from the inside and unlock it and bring stuff in through this port that you had to seal off. But then you have these wonderful bioindicators like mice. If you didn't succeed at sterilizing everything, they became contaminated, and you had an instant readout as to whether you were doing something right or not. So you got really good at this. Otherwise, you were asked not to work with germ-free animals anymore.
Yeah, we did this with tissue culture. So
yeah, exactly.
I would
right,
train
exactly.
the tissue culture without any antibiotics and antimycotics, and
right.
And then or like work with tissue culture on the bench rather than inside of the hood, and then see whether you can manage not to contaminate them.
Yep, that's good. That's good stuff.
So I used to work in a microbiome lab during my civic service. I think we discussed this in the very first TWiV that I did. And at that time, from that time still, when I open the lid to any agar plate, I hold my breath. So I cannot. It's an automatic thing. I cannot breathe and open.
Sure. The space agency, all of them, but ours in particular, because we've sent so many things into outer space and landed them on various moons and planets, etc. They're really concerned about contamination and introducing life forms into other places. Mm-hmm. So do you think that they have the most stringent of all facilities for ensuring the fact that no contamination has occurred before they blast off into outer space?
It's possible. I mean, I think the cleanest place in all likelihood are chip manufacturers.
Yeah, electronics factories. That's true. Mm-hmm. That's true.
Yeah. So the moment there's a massive financial interest in stuff, typically trumps everything in the end.
Yeah, the space agencies overlap with that. When they're assembling even satellites for Earth orbit, they're done in a clean room.
Yeah, that's right.
And that's done because there are components where a speck of dust will destroy the thing.
Right. Right.
But whether that's the measures you take to be microbiologically clean are different, and I suspect a lot of clean rooms, so-called clean rooms, even in the chip industry, are probably loaded with bacteria and viruses.
I would agree.
And maybe fungi, because nobody cares about those. They're too small.
Dust. They were dust.
The ISA is full of fungi. It just published an article on it.
Right.
Common Earth.
And the direction of the safety, of course, is different, right? If you work in a chip factory, you want to protect the product.
Sure.
Whereas, like, if you work in a laboratory, you want to protect yourself.
Right.
So, like, you look at it from a completely different angle.
So, TWiV was invited to JPL by some microbiologists. They want to show us how they keep microbes from going into space. That'll be fun.
That'll be great.
We're going to go out there.
What's their proof?
Well, I'll find out. So I was invited she said, we have a small crew of microbiologists here. It's in Pasadena, and we'd love you to come out. We'll show you how we do this, and we can do a podcast from there. So we're going to do that this June. Yeah,
so cool.
So as long as they take the tardigrades with them, everything.
Yeah,
that's right.
Oh, you're right.
So and TWiV, of course, went to the Needle in Boston.
Yeah, I'm sorry,
before it was hot. So that was pretty cool.
So wait, before we go to biosecurity,
yes.
One thing that's actually close to my heart, I would like to differentiate between biosafety levels and risk group agents. And that's actually something that's important, right?
Okay.
So biosafety levels, these are standards for facilities. So they have nothing to do with agents. They're the measures that you take to be safe from whatever it is, assuming that whatever that is very dangerous. But people make often this mistake of saying Ebola virus is a BSL-4 agent. And that's not true because there are no BSL-4 agents, right? There's BSL-4 facilities. And then there are risk group agents. The risk group agents, they are divided into 4 levels as well. There's an international risk group classification by the WHO. And then there are national risk group categorizations. In many different countries have these. And they differ from each other, and that's where this is important. Ebola is an easy example. Ebola is a risk group 4 agent no matter where you go, simply because it is so lethal if you get it. And so that requires work in a biosafety level 4 facility. That said, biosafety level 4 is a phrase that is an American phrase. And these levels are called different things in different countries as well. So if you go to the UK, they're called P1 to 4, I think. In Russia, it's P3 to 1, so they actually go the opposite direction. So the 1 is the highest, the 3rd is the highest, so on. In Germany, there's S1 to S4, and so on. So they're different designations for these laboratories. And because countries have different endemicity for certain agents, therefore different research needs for those agents, and different prophylactic measures in place. The risk group categorization and the need to work in particular biosafety level categorizations is different. So if you look, for example, at tick-borne encephalitis, tick-borne encephalitis is very endemic in Germany and in Switzerland and in Austria. And there's a vaccine that a lot of people get. So I have been vaccinated as a child. I've repeatedly been vaccinated against it many times later. This is a tick-borne virus. And if you are a kid and you grow up in Bavaria, in Germany, or in Austria, you are going to have ticks, tons of them if you run around in the woods, right? And so therefore you will be exposed to this virus. And so because you're vaccinated, there's not really a problem. And that therefore means that if you have a research program in these countries and you work on tick-borne encephalitis, you vaccinate the laboratory workers, and therefore this is not a BSL-4 virus in those countries.
But here it would be, right? Here it would be.
Right. And here it is not easy to get a tick-borne encephalitis vaccine. It's not licensed for use in the United States. You can probably get it under certain conditions and so on, but it's not a usual thing that lays around in the general practitioner's office when you go there. And I haven't seen a program here where people routinely get vaccinated against TBE, for example. And so therefore there's a bunch of, it's not all of the strains, but a bunch of the strains of TBE are classified as risk group 4 agents here, and then requiring the highest level of containment, which is BSL-4 here. Another example for that is Crimean Congo hemorrhagic fever virus. Also tick-borne virus causes hemorrhagic fever, is highly lethal. That is a BSL-4 virus in Europe. It's so requires BSL-4 laboratories, risk group 4 agent in Europe, and also risk group 4 agent in the US, but a risk group 2 agent in Russia, therefore requiring a BSL-3 equivalent kind of laboratory. And that is because it's endemic in this country. A lot of people get it. And so the moment you require the highest level of biosafety, you're reducing the possibility of doing research and actually helping somebody with it.
Right.
Mm-hmm. So this is kind of like going into the discussion about priority agents and so on. Priority agents are different in every country depending on how likely it is that you get something. That's why we call many agents here exotic, which in a way is kind of racist. So if you because it's exotic to you, and just because it's exotic to you, it doesn't mean it's exotic to many other people. So we used to have these, tropical medicine books, and if you go back into the 60s and 70s, these were the books that list all these very crazy, weird things. But of course, they were only weird to people who live in Europe and the US. But if you live in Africa, I don't know, river blindness is not completely foreign to you. I mean, you have probably heard about it. So
a little bit.
Yes, and so this is a big issue. A BSL-4 laboratory is insanely expensive to maintain, and especially if this is not just a small laboratory where you have a biosafety class 3 cabinet or something, but something that where you actually have space and you want to be able to do mouse experiments or even non-human primate experiments and so on, vaccine development. These are huge facilities, and they cost millions and millions of dollars to maintain, and they cost tens to hundreds of millions to construct. So the buildings that we have here on the campus where I'm working, together they easily cross the $1 billion mark. So it's if you have an actual public health problem with a risk group 4 agent because you classified it as risk group 4, and that means you have to have a BSL-4 lab. Many countries can't afford these laboratories. There are only about 30 BSL-4 laboratories in the world, and if you subtract laboratories that are just there for contingencies and actually not running on a daily basis, and you take everything out that cannot even run a mouse experiment, you're probably going to end up with 10 to 15 or so. So most countries, especially poor countries that are highly affected by dangerous agents, wouldn't be able to do anything if they would classify it that way. So the risk group pathogen classification is a double-edged sword. On the one hand, asking about risk for the laboratory worker, and at the same time, what's the risk if nobody works with it? And that's why there's this crossover between these two different classifications.
So the risk groups are determined on a country-by-country basis by what sorts of agencies? Like here, would it be CDC?
Yes. So here would be CDC. In Germany, it would probably the Robert Koch Institute.
Okay.
So like the typical public health institutes would probably look into this and make their recommendations. So the main publication in the U.S. is the BMBL, right? The Biosafety in Microbiological and Biomedical Laboratories book. And that's published by the CDC, the U.S. Department of Health and Human Services, and maybe the U.S. Department of Agriculture. And that's in its 5th edition, I think, and I think the 6th edition is coming forward. And so that book, if you go in there, will tell you that in the U.S., if you want to work with chikungunya, you have to do this in a BSL-3 lab, I think. So that is the thing for the U.S. and similar guidances exist in many other countries, especially in the developed countries, of course, but also increasingly in the underdeveloped countries.
Yeah, it's a free download on the CDC website.
Yes, it is.
5th edition.
Okay, so what distinguishes the risk group agents from the priority pathogens and the select agents?
Okay, so the risk group agents are based, again, it's a biosafety classification. It's like what is the consequence for you if you get infected with it, and what can we do to prevent this, right? And that's why I said the biosafety and biosecurity might overlap to a certain degree, because if you are not properly trained to work with Ebola virus, you will not get access to the facility where you can work with Ebola virus. So we are both secure from you and you are safe from yourself. So there's a little bit of overlap there. The other categories are about priorities in terms of how important do we think is something. So the denied priority pathogens are looking into where do we have weaknesses as a nation in terms of public health defense? What is something that we need to look into more than that we have ignored before? And so this also exists in all different kind of countries. They have different priority lists. So here we have the denied priority pathogen list, which is the list for NIH to look into. But there's also a CDC list called the CDC Bioterrorism Agents and Diseases list, I think, and they list in agents in category A, B, and C based on the idea that these can be used in bioterrorist events, and we are not prepared for them. And so necessarily there's a big overlap between NIAID priority pathogens, which look at it from a public health perspective, and the CDC Bioterrorism Agents, which look at it from a bioterrorism perspective, because the consequences are the same. And so therefore the defenses against them would also be the same. There's also the WHO also has a list like that. It's called the WHO R&D blueprint. So R&D for research and development. So they list particular agents that they are considered of from a global concern that they might be more important in the future than they currently are. So on the WHO blueprint, I think there's Ebola and Lassa. Crimean Congo, I think, is a new Nipah, Zika, probably. Not really sure whether MERS is still on there or not. But these are basically agents that came out of nowhere. Nobody had them on the radar screen. Suddenly, they caused a big thing that nobody really expected, and then thereby showed the world how unprepared it is. And
you mean like Marburg?
Okay, we should. Right. So
yeah.
yes, so it's interesting for me that Ebola has shown us what can happen. nobody would have predicted that large outbreak from 2013 to 2016 in Western Africa, right? Not even the Ebola specialists. I don't think anybody had it on the radar screen that such a big outbreak could actually happen. But interestingly, nobody talks about Marburg, and as far as we know, Marburg behaves exactly like Ebola. The transmission is the same, the disease is the same, at least on face value. And actually, if you look at absolute numbers, the lethality of Marburg is actually higher than that of Ebola. And yet, when people talk about priorities, they single out Ebola, and you hear Marburg very little. And so these are discussions.
Unless you go to Marburg.
Right. Yeah, except if you go to Marburg. So there's different groups that basically say, like, we need to focus more on this, and that ultimately is attached to funding pools where we, like, DITRA, for example, for the Army and other agencies that are out there, that would say, okay, we really need to look into this because of potential consequences that could come tomorrow. Also, right now, there's nothing attached to that. And then there is, aside from all of this, which there are select agent groups and Australia groups and so on, and these are classifications from a security point of view. So the select agent list that's federal law in the United States that regulates who can have access and possess and do what with a particular agent on a particular list. So it is a criminal offense for you to have Ebola virus in your fridge at home. Yeah, you're not allowed to do that, right? So, and
I'm going to go home right now and look.
Yes. Well, but this is,
when potato salad goes really bad.
Yeah, that's a fact.
So on first glance, of course, it's a very obvious thing, but there come real consequences with this, right? So, for example, if you have an outbreak of Ebola virus in Africa and you're a clinician and you go over there and you take a blood sample and there's an Ebola virus in that blood sample, then you're technically in possession of the select agent at that very moment. So, do you have permission to be in that? To have this in your hands, right? And so it makes it very complicated in terms of who can send which kind of sample, or like, an animal and you infect it with a select agent. Does the animal by law become a select agent at that very moment or not? Right. So there are many questions like this.
I think probably intent and knowledge have a lot to do with whether any of these would be prosecuted. Like, do you know you have Ebola in your refrigerator, and did you intend to put it there? Would be major questions.
Right. But you have to be very, very careful with it, and
yes.
You have to understand the law the moment you touch any of kind of these agents. And so when you go into like a BSL-3 or BSL-4 laboratory space, especially BSL-4, where pretty much almost every agent we work with is a select agent, you have to go through all different kind of training and background checks and so on. And so
select agents determine who's allowed access to particular viruses or bacteria or what have you. Priority pathogens are what we as a country think we ought to be working on. Risk group agents are determining how risky it is for laboratory workers to work on these agents.
Correct.
Okay.
So if you look at Ebola, everybody's favorite child, right? So Ebola is a risk group 4 pathogen, because if you get it, we don't have a cure for you, and you have a 50% chance of dying. Because of that risk, you need to work at it in the U.S. in a biosafety level 4 laboratory to decrease that risk. It is a select agent because people think it can be misused for any kind of nefarious purposes and so on. So therefore, you are not allowed to have Ebola virus without being on a particular registry, particularly trained and so on. So you cannot enter the BSL-4 laboratory to work on it if you are not probably cleared for and have select agent clearance. And we are working on it in almost every single BSL-4 laboratory in the United States, because it is both a priority agent for public health purposes on the NIAID list, as well as a potential bioterrorism agent on the CDC group. And then the last list that is missing here is the Australia group, and the Australia group looks at all of these agents from an export control concern. So there is always the worry. So traditionally, this was built for technologies. Right, so if you build an uranium enrichment centrifuge, that's a technological feat. It's not easy to do. There's no reason for anybody to have an enrichment centrifuge except if you want to build a nuclear weapon. And so therefore, these kind of centrifuges fall under export control. You're not allowed to put it on a truck and drive it to Iran,
right?
Because you're worried that other countries might use it for things that ultimately destabilize your own country and your own national security interests. And so viruses, for the same reason, from the bioweapons angle, are being put on this list. And so the Australia list, I think this is a voluntary, basically an informal group of different countries that look at agents where they say, like, no, we don't think this should be exported without a lot of scrutiny into other countries. And so that is partially translated into national laws. And that there's a phrase called deemed export that makes it very complicated, for example, for foreigners to work in high security facilities, because of course they travel back and forth between different countries, and not only could they theoretically take agents back and forth, but they also bring knowledge back and forth, and even knowledge, of course, can be a good for export.
Incidentally, I just have to interject while we're having this discussion on risk. A thunderstorm is rolling through, and I just got a tornado warning on my phone. So if I suddenly go offline, it may have something to do with that.
Do you have a tornado basement you're going to run into?
We do have a basement. I don't know if it's a tornado basement, but I guess maybe we'll find out.
All right.
Yeah. So one of the things that I think is sort of interesting with select agents is that a lot of the rules about select agents came into play in the sort of early 2000s after 2001. Yes. And so when I was in graduate school, we actually had to have training on a lot of different aspects of safety, both biosafety, but in fact, there was a talk we had to listen to about select agents each year. And I always found it fascinating that there were rules about who could be employed in labs working on certain types of agents. And we often had to hear about, well, this is what happens if you're going through your lab's freezer and happen to find something hidden in the back that you forgot was there, that suddenly has gone on a list that didn't used to be on a list. And so I think that in that period of time, there was a lot of change that had to happen in a number of different infectious disease labs.
Yeah, so this is from a logistical point of view, this is a huge thing if you go into BSL-3 and BSL-4 laboratories, because you need to account for where all your agents are. And there are, of course, inspections by the CDC, and they will go into your records and say, it says here you worked with Ebola virus 5 years ago, blah, 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 blah. Where's that tube? Right, and then you need to be able to go to the freezer immediately and say, here's this tube. And then it says on the record that, there are 500 microliters in that tube, and, they're checking.
So that's why it was particularly embarrassing a few years ago when they found some vials at NIH, right? Correct.
Yes. So this is, and of course, if you go into the past, and especially if you go into academic labs, there's a lot of people who have worked with something 20, 30 years ago, and then they finally retire or leave, and a lot of stuff just stays in the freezer, and then nobody wants to throw it away because they think, like, maybe this is important, maybe we still need it, and so it slowly gets into this cluster of ice in the back of the freezer, and then one day somebody does a test on it and says, oh my God, there's X, Y, and Z here, and so that is a problem. And of course, if by that time it's a federal offense to have it, that can cause issues.
So when poliovirus finally goes on this list, it's going to be a huge problem.
I was just going to ask that. Will that become a select agent when it's eradicated? I suppose so, right? But we do have vaccines, right?
Yeah, I would assume so. I think we talked about this in the last episode in terms of vaccination coverage, right? So if we eradicate polio, will people continue to vaccinate against it?
Yeah, right.
As long as everybody continues to vaccinate, we don't need to be worried about it at all. But there will be people out there who say, well, there's no polio around anymore, so therefore we don't need to vaccinate. And at that very moment, you're opening Pandora's box, that if somebody gets access to it, it can be used for something, and then it will probably become a select agent. And for the same reason, it might also become a BSL-4 requirement and a risk group 4 agent, because if you're not vaccinated against it, and maybe the vaccine is not available anymore 20 years after or so, because there's no need and no financial incentive to produce it anymore, then of course the consequences of getting polio can be quite severe. And so therefore, so it's all of these factors that play into this.
Yeah,
that's right. See smallpox.
So this list is interesting. It's It's got both human and agricultural agents on it, right?
Right.
Should.
You're looking at which list now?
The select agent
Select
list.
agents.
The select agent list. Okay. Yes, that's right. For the same reason, of course, because there is agents that can have massive effects on national security if it gets into the wrong crops, for example, or the wrong animals. And so you don't want to make it easy for people to have it and basically play around it. And the punishment for having a select agent and not being cleared for it is very severe. It's years of jail time. And so it is very stupid to just say like, oh, I'm having this agent that could destroy all the barley, and I'm keeping it at home just in case, because if you get caught with it, you have a big problem. So it doesn't make sense to have legislation about this and say like, no, there's absolutely no reason for a non-scientist who doesn't work into one of those facilities to have any of these agents in their hands or at home or something.
It's quite a list.
Yeah.
It's quite interesting.
And by the way, if you kill all the barley, there's no more beer.
Yes.
That would be
That
sad.
is sad.
That would be sad.
And if you look at the list, so if you, I haven't looked at it in a while now, but if you look at the webpage, they probably point out the tier 1 agents now. So there are particular agents on that list for which even more special restrictions apply than for the rest of it. So Ebola is one of them. Marburg probably, Francisella probably,
well,
like those agents.
They have selectagents.gov. They got the right URL. How about that?
Yeah.
Yeah, this also gets reviewed on an annual basis. There's a review committee that looks into this, that changes the list depending on whether we have novel countermeasures or not, whether we learn something about an agent or not. So some agents get taken off the list, others are being added. You can probably have an entire episode of TWiV just fighting over whether it's useful to have some of these agents on the list or not. Because the problem, of course, is the moment you have all these laws applied to it, there's a huge program that you need to have in your facility to make sure that everybody is probably trained and cleared.
Cost of compliance.
Agent, right, and that is severe cost, of course. And one of those things is, for example, just background checks. Right? I mean, people, you cannot work on select agents if you have a criminal background or if you are part of particular associations or cults and so on.
Or if you're from certain countries.
From a certain
That's
country,
right.
yeah.
If you're a foreigner and you come from certain countries, then you have an issue as well. And so the FBI will look into this, and depending on how complicated your background is, background investigations are very, very expensive, because they call up all your neighbors and say, like, was he a good being in 1983? So
interestingly, last I checked, Saudi Arabia was not on that list of countries, even though most of the 9/11 hijackers were from there. So
that is correct.
Yeah. Anyway, continuing on.
Wow. It's quite.
By the way, selectagents.com appears to be available if anybody's interested.
Yeah, they got .gov, right?
They got the .gov.
No, I don't really want it.
But you can see where the costs are coming in, right? If you want to do a Marburg virus non-human primate study that is statistically significant, where you want to evaluate one antiviral against like a control or something, so. Ultimately, what you need to do is you need to find a BSL-4 laboratory, number one, which there are not many. Then you need to find a spot in their schedule to do this experiment. And of course, because there's so few facilities, you're going to go on a list, like basically and maybe we'll do your experiment in a year from now. Then you need to have people in this facility who are cleared through all of this, so have their background investigations, have their trainings done, have their security risk assessments, everything that is associated with all of this, which costs an insane amount of money. Then you can hire that person into the facility, but at that very moment, that person is not trained in biosafety level 4 practices. And it's not like you take a 1-hour class and then you can work with Ebola, right? Because the consequences are severe. So you need to go through all different kind of suit training and so on. And then when you have passed all of this, then you need to typically be shadowed by somebody, not allowed to do something for so many hours. And then you can slowly start working on it. All of this has not yet gone through any kind of institutional biosafety committees that look at it from a dual use perspective and a gain of function perspective and all these other things, and how it will be regarded internationally, because the moment you start working in a biosafety level 4 space, most of the agents that you work with are CDC bioterrorism agents and therefore also considered potential bioweapons agents, which means other secret services from other countries will look at your facility with a suspicious eye of what you're doing there. Then, of course, you have the ACUC that needs to look at the animal welfare part, and then the money that it takes to actually run the animal experiments. So if you take, and then the complication of not being able to do a lot of the things that you would typically do because they're not possible in the biosafety level 4 containment, because we don't have this machinery there, because we can put it in, or because we can't use these tubes because with 3 sets of gloves it's really difficult to open them, or all of these other complications that come with it. So it makes it incredibly challenging from a logistical point of view to do these experiments, and it makes it also very complicated to explain to non-experts why certain things are being done the way they are being done.
Right.
Well, we visited the needle even though it was not yet active, just to put on a suit, we had to get special permission because we didn't have the full training, right?
Right.
They say, okay, we normally don't do this. You need to train for weeks and weeks to put a suit on, but we'll let you do it because. But
it was a very closely supervised setting, and there were like 5 other people who had the training who were standing around.
Yeah, because you can imagine something might go wrong, and you know how to respond to it.
One of the things we learned in that is if you put on the suit and you forget to hook up the hose, you'll suffocate in a matter of minutes.
Jeez.
You're in a giant plastic bag.
I wouldn't say minutes, but I mean it's becoming uncomfortable.
Yeah,
and you
very uncomfortable.
You will have enough. We'll have enough time to open your zipper and get out of it. I mean, you will not suffocate and die.
Right.
But yes, these things are. I mean, you need to know how to use them. You need to know how to get out quickly if there's an emergency, both out of the lab and out of the suit. The suits themselves, of course, are also expensive, so you don't want to have people fool around with them and say, "Oh, look, it exploded." There's a lot of stuff that comes with this, and it's a little bit of a problem when you work with people who come. I mean, when I started in all of this, I did my postdoc at Harvard. I came from academia and academic background, and you're so used to saying I just want to clone this thing from PCAC into PCDNA 3.1 plus tomorrow. So I just ordered the primers and do it tomorrow. And so this is often not possible in government settings in these kind of laboratories. If you work at NIH, this is very you have to go through a review board because anything that you do recombinantly needs to be approved by a committee. So you better plan your experiments the right way when you go to the IBC, and you write in there that it might be cloned into this vector and into this vector downstream, because if you want to change your ways, it needs to be reviewed again. And that all comes from these 2 angles. The one part is the actual biosafety part, so that again the protection of the laboratory worker and so on. The other part is a perception question of people who are skeptical about what is being done in these laboratories and why are you doing X, Y, and Z. Right. I mean, you guys discussed this about vaccines and about many other things on the show many times, right? It is not necessarily easy to explain science to people who are not scientists. There's one of my favorite shows of all times was the X-Files, and there was an episode, I think in the 5th season or so, called the Postmodern Prometheus. It's a black and white episode, and it's very Frankenstein's monster-like. So there's this monster that runs around in a village and I think kills people or so, and Mulder and Scully need to somehow solve it, and I think they even call it the Mutado or something. And they go to this scientist who locally works there, and it's a black and white episode, so it's very nicely with lightning in the background and completely hyperbole. And they go into this laboratory, and the guy is a specialist on Hox genes, so developmental stuff. Mm-hmm. And he very proudly shows off to Agent Mulder that he has this fruit fly, and the fruit fly grows legs out of its mouth, I think it was. And then Agent Mulder says, "But why would you do such a thing?" And then the guy says, "Because I can." Right? And so this is, and of course this is an image of scientists, right? Mm-hmm. One of the stereotypes about scientists is this lonely kind of geek and stuff who doesn't have a private life, never had a girlfriend and stuff, and then he brings doom because he wants to have revenge, and there's fumes behind him and all of this. And it's easy to make jokes about it, but a lot of people I mean, there was Sarah Palin's comment about defunding NIH because these people are crazy. They're doing research on fruit flies. Right. So, I want to believe that she did this deliberately because she knows she could target certain people, but it's also possible that she really doesn't know any better. Right. So,
I picked B.
Yeah.
Well, so there's ultimately a question of communication, and when you saw it with the needle took forever to go hot because of local opposition, because of the fear that Ebola virus is something that this could get through a crack in the air and kill everybody in Boston, and I understand where fears come from. Fears come from not understanding the particular topic, and scientists are not necessarily the best people in being patient with people who don't understand the topic and explaining it in a way that people can. And the vaccine debate is one of those things. I mean, I think all of us are growing very quickly, very impatient with people who don't believe in vaccines. I also don't know how to do it differently. Because my discussions certainly have never changed anybody's opinion, whether pro or con.
Balderdash.
So this is an issue, and so when you have a small BSL-4 facility being built somewhere, there's going to be concern about these agents being released in some kind of a way. There are going to be other countries who look at these BSL-4 facilities and say, well, it's definitely clear that they built bioweapons in there to attack other countries, right. And so therefore transparency measures are very, very important. And one part of transparency measures is that there's a record for everything that is being done, and everything is being looked at and probably vetted and probably recorded. And so therefore you cannot come up with an idea anymore, just nilly-willy in a BSL-4 lab and say, and tomorrow I'm going to do that. Mm-hmm. That goes out of the window. Bad pun. Doesn't go out of the window.
No, hopefully it does not.
But influenza through the window.
That's just, we need that kind of science elsewhere, not in a BL4 laboratory, though. And that's fine. We could do it in my lab. You can have an idea tomorrow and do it. But, and that's why I would never work in a BSL-4 lab, because I still want to have the flexibility to do what we want to do tomorrow, right? Right. So we don't work on certain kinds of pathogens, but that's fine. Yeah. So this brings us to biosurety, mayit Biosurety I just put on the list because we should mention it. I mean, biosurety is a Department of Defense term, and it ultimately just subsumizes all of the above. So it's ultimately a program that is implemented by the department to make sure that all select agents are properly inventoried, all biosafety regulations are being kept, all personnel is reliable and is being monitored at all times. We didn't talk about, we talked a little bit about, people not being able to come here from a particular country and so on. But with that also comes the idea that everybody watches everybody in a positive way, right? So if somebody is off in any kind of way today, that we pay attention to that the person doesn't go into the laboratory. So you don't want to have somebody who, was broken up with by his spouse yesterday and necessarily go into a BSL-4 laboratory today. Right? It would be smart probably to give them a few days. But for the same reasons, people might develop drug addictions while they already have permission to work with all of these agents. And so people need to look out for each other ideally in a way that doesn't make everybody paranoid and creates a hostile work environment. So all of these measures above falls under biosurety. And as far as I know, biosurety is a term that is only used in the defense facilities, not in the other.
How is that handled in terms of monitoring your coworkers and doing so in a way that doesn't cast blame and doesn't make everybody paranoid? Because I know in various regulated industries handle this in various ways with varying degrees of success. How is that done? I mean, do you have group discussions on a regular basis? Is there a reporting system? What's the setup?
Well, I mean, the first thing so this is probably done different from facility to facility depending on who's running them, right? What we certainly try to do is there should never be any kind of retaliation is too strong of a word. But if somebody says, I don't feel like going into the biosafety level 4 laboratory today, that should simply be okay. So that allows people then to not necessarily to have to justify why that is, right? I mean, people who work in these facilities typically want to work in these facilities, so it's not like they're trying to find an excuse every day not to do any work. When people come up with a reason why they don't feel like it's a good idea today to go, you just need to create an environment where this is okay to say, and everybody says, "Oh, sure, I'll take over for you." And as far as I can see, that works pretty well in most facilities. Research by definition is teamwork, right? And teamwork only works when you have a certain trust in each other and a certain transparency around. It's a little bit like having very strong whistleblower protection laws, right? So here's the same thing. I mean, it's neither in the interest of the laboratory worker nor in the interest of the PI or the facility that something bad happens. So you automatically always are on the side of caution. And so if somebody is concerned, there's simply no problem.
Is there some kind of anonymous reporting system if you think somebody's got a problem?
Yes. So most facilities deal with this in different ways, but yes, there's those ways. There's also places where people can go to talk about particular issues. So we have a nurse in the facility that deals with all of these things. We also have reliability screenings by trained psychologists or psychiatrists probably every year, where you can report and talk about concerns, especially if you have concerns about another coworker, if you think something is off. And of course, you have 16,000 phone numbers that you can call at any given time. So there's the security and the safety in the modern BSL-4 facilities they're very well thought out. They're very well built into the system, and it shows because there haven't been any laboratory acquired risk group 4 agents in accidents in decades.
Well,
in the West.
I mean, the thing that comes to mind is how much of this was put in place after the Amerithrax attacks, because there is a line of evidence that was a rogue employee problem, at least partly, right?
Right. Well, so there's debate about this, and actually, I don't want to get into this because
right. I mean, that's why I say there is a line of evidence, but there are concerns that some of the people who were cleared to handle all these things and that everything was hunky dory got access to them, and how much of this has changed since then.
Right, but so just to stay technically clear here, I said BSL-4 facilities, right, and that was anthrax. Right. That's BSL-3, and so of course the stringencies for BSL-3 are laxer than for BSL-4.
Right.
So it's a little bit different. And then even before that, that was USAMRIID, right? And USAMRIID, the training that you needed to go through to be into in these laboratories and the permissions that you needed to get and stuff were very strong at the time already. So I did my master's thesis at that facility in 1998. I think, and I would not get permission to get into a BSL-4 laboratory because I was a foreigner and I was a student. There was no need for me to get anywhere clear of this, and so everything I did was in a BSL-2 laboratory, and then I had other people who would do the experiments if they were necessary. Right? So it's not like everything was the Wild West, and then this Bruce Ivins case came around, and then people woke up and said, "Oh my God!" I mean, people were very aware, especially of the safety issues.
Right.
Before that, I mean, in fact, the first BSL-4 laboratory that was ever built was this outside trailer that Carl Johnson created outside of CDC for Lhasa, right? And that was and the reason why it wasn't a trailer outside of the building is because everybody knew this thing kills, and so we want to have it contained and only very few people being in touch with it. People typically don't like playing with their own lives, so they pay very much attention to these things the moment they understand the consequences. The only accidents that happened with risk group 4 agents that I'm aware of typically happened in those either very old days. So if you go back to I want to say 1978, a year after 1977 probably, the first year after the first recorded Ebola outbreak in Sudan, there was a laboratory-acquired infection reported down in England by a person who stuck himself with a needle, right? And then all the other accidents that came after that were typically needle stick incidents during animal experimentation until new devices came along that in which you are able to restrain an animal without having to have a hand behind the needle.
Right.
And so that's how everything is being done right now, right? So it's very unlikely that accidents like this nowadays happen, and they haven't happened in a very long time. And so it's the same thing with release. There's a lot of discussion about how allegedly easy it is for agents to be released from facilities, and I seriously doubt that. I mean, insider threats, of course, are always a problem. You will never have 100% guarantee that every measure will hold and that there's not a loophole somewhere, of course. But I would say, just to be able to walk into these laboratories, you're already so vetted and cameras everywhere and so on. I really don't see it as a very easy feat to steal something and let alone like that nobody knows about it when you did it. And then we have all the laws that if somebody catches you with it, that there are severe consequences for you. And then it's going to be very difficult to do something with whatever you took. So there's, the risk is never zero. But I think these facilities do a very good job in reducing it massively.
Alan, did we have to get some kind of low-level background just to go into the needle? I think so, right?
I remember some kind of they needed to see some IDs and such, and I'm not sure what all they ran on that.
I think beforehand we had to send them stuff so they could.
Yeah, that's what I mean. We had to send them some paperwork about who we were, and I don't know what kind of a check they ran on it, but I know I'm findable in multiple databases, so whatever they did.
So Jens, when did this Biosafety 1, 2, 3, 4 start in the U.S. roughly?
Oh, that's a good question.
Because I know
it's there for a long time,
but not the 60s, no, because.
And I don't think, definitely not 4, because 4 really came only along with Carl Johnson and so on. I don't think that level was there. One could probably go back. So the BMBL is in its 5th edition. One could probably go back to the 1st edition and see from which year this was and whether they have these levels there. They certainly have always been around since I got into science. At least since 1992.
So if you,
but the select agents are new, right? The select agents. There was a list before that was called restricted agents. I remember that was like in probably the end of the 90s or so. They got a little asterisk in the different textbooks and stuff, and those were typically Nairobi sheep disease, agricultural agents, and so on. And then I think the idea of select agents really came about after the anthrax letters.
So
it's actually written in the Patriot Act.
Right.
Yeah, there you go.
If you wanted to build a BSL-4 today, say, Jens, is there a blueprint that you could use? Are there instructions somewhere on exactly what you have to do? And do these things change over time? So is the needle different from a BSL-4 built, 15 years ago?
Well, number one, there are companies who specialize on this. So you can actually go to architectural and companies and say, we want to have a BSL-4, and we want, and they will know what to do. So many of the modern BSL-4 facilities are mirrored to a certain degree on past facilities and then improved upon. So, for example, the new Chinese facility that in Wuhan is heavily influenced by how the facility in Lyon in France was built. So they get the subject matter experts from France flying over there and advising what is necessary and what is not. So there are blueprints for that. With that, of course, come always the question of what's the purpose of your facility. So if you want to do something completely new, then of course there's no guidance, right? So our facility is unique in the world because we have medical imaging in the BSL-4, so we can do MR scans and PET inspect scans on animals within biosafety level 4 containment that doesn't exist anywhere. And so when that was built, there was nobody who could advise. So it was, and of course that's also what made it very expensive, right? Because a lot of things needed to be MacGyvered in the end and figured out how this can be done safely, while at the same time you still can send technicians to the machine and repair the machine if it breaks. Right. So whenever you basically want to push the envelope of science and you want to do anything new, let's say even a new species of animal that you want to use, at that very moment you're going to go through some real bureaucratic pain, because you will have to show that you can do all of this safely and at the same time adhering to ethical animal welfare issues and so on and so on. So this is hard. Doing something really new in a BSL-4 environment is really hard.
You can't just duct tape it together like you do in most labs. Yeah.
So if something breaks and you need someone to come in and fix it, do you have to shut down the thing and decontaminate it, or what? Do you send someone in a suit?
Typically, yes. So there are different things how you can handle it. So the easiest thing is if it's not too expensive, you just trash it and replace it. Mm-hmm. That works for some things, because of course it becomes a cost issue of like how much time does it cost to get a technician trained and do all of this when the machinery costs $200 and you can replace it. It might be worthwhile. Then modern machineries, so the things that we are choosing now for these facilities, we typically look for stuff that can be steered from the outside. So you have your CPUs, your computers, and everything else, not in the BSL-4 environment, but you have it outside, so that you have as little as possible on the inside, so that you simply reduce the risk of breaking. Then there's the possibility of training specialized people from companies. So some companies produce BSL-4 specific equipment, and they are willing to send technicians through the BSL-4 training so they can actually put a suit in, they get all their background checks and everything else, and then they can go into the BSL-4 laboratory and repair equipment as much as that is possible. That's not really a favorable thing to do, though, because it's not really financially advisable for companies to do that, and it costs a lot of time. And then there's the ultimate thing of decontaminating and taking the machine out, repairing it, and bringing it back in, with the risk, of course, that most machinery takes a hit with every decontamination cycle, and so your half-life of your equipment goes down considerably.
I guess for an MRI you would do that, though, right?
Well, so for the MRI, that's why there was a lot of thinking involved in our facility on how to do this. And the way how the IRF is built is that the MRI itself is actually in a BSL-1 space, and then the tube in which the animal would be in is a plexiglass tube that cannot break and is connected to the BSL-4 lab to a table. So the tube itself inside is BSL-4, but everything around the tube is BSL-1. So the only thing that cannot, there's no electronics associated to this tube. So if the MR has any kind of problems, we can take regular technicians that will be escorted into the facility and then repair that machine, and they will never have to see the inside lab space.
That's cool.
That was a massive architectural undertaking to build it.
I bet.
Neat.
Yeah.
So you're in Frederick, right?
Yep.
And there's this integrated research facility. It's a BSL-4, right?
Mm-hmm.
And isn't there one nearby also?
Yeah, there's the United States Army Medical Research Institute of Infectious Diseases.
USAMRIID, right? They have a
USAMRIID, that's right. That's right next door. And then there's NBAC, which is the Department of Homeland Security BSL-4. And so we're all three together.
And Camp David is just up the road.
Really?
So I hearken back to the era where Lassa fever was discovered here, and I think we've talked about this before too. It was one of our first episodes on TWiV, and Gerald Eddy, who was one of my classmates at Notre Dame, ended up at Frederick at the USAMRIID, and his job was to sequester as much immune serum from Africa as he could, so that if you ever got contaminated with the virus, you could get the immunoglobulin to save your life.
Penny Pinio.
To keep with the TWiV theme, I think he was the first person who published a plaque assay for Ebola virus.
Really?
I'm pretty sure.
Cool.
Let me check. I'm gonna look it up.
Good friend of mine.
So, what did he do that in a BSL-4?
No, they didn't have BSL. They didn't have BSL anything.
No, we're talking about Ebola now.
No,
sorry.
The plaque assay he would probably. Let me see. I'm before I make something up here, but I'm pretty sure it was him.
Well, here on TWiV, we don't make things up.
No,
right?
No, we
we speculate a lot though.
Problem is, of course, every paper in the world is doing plaque assays on Ebola.
On Ebola, yes.
It's good. I like it.
You just have to reverse date sort them.
Yeah, that's right. That's pretty much what I'm doing. I was wrong. Plaque assay for Ebola virus by Moe, Lambert, and Lupton, not Eddy. Yeah, but but it was definitely the same generation, and I know the name Eddy from many papers.
Mm-hmm.
Well, you know what? That's a show, and I think we'll save gain of function and dual use. We'll have you back, Jens. What do you think of that?
It's a whole other subject.
Sure.
Because that's a whole other subject with some of the recent things that have been going on. And
it's a great excuse to have Jens back on the show.
And also synthetic biology, etc. So we will do that. Is that a deal, Jens?
That's a deal.
And also, you said you would get
Skype.
Yeah.
Oh, no, sorry.
No, Ian Crozier on, right?
Yes, actually, I talked with him today about it, and I'm psychologically pressuring him into this. So next show, if you want to, I will just grab him and bring him on.
So how much battery space have you got left on your phone?
He's on his regular.
He's on a landline.
Oh,
landline.
Oh, okay.
Because we couldn't figure out how to Skype.
Government issued landline.
Government issued landline.
All right, let's do some picks.
Hey.
Jens, you have a pick ready for us?
I do. I have a very cute little pick that fits many of your discussions in recent episodes. I hope nobody ever picked it before. So this is called Forvo. It's forvo.com, and this is a pronunciation database.
Very good.
This is it's forvo.com. So this is new, and it's being developed. And if you have an interesting word that you think nobody knows how to pronounce, you can actually upload it there and build a database. And they have typically a list for words of the day or words of the month or so. And if you ever wanted to know how to pronounce these funky Icelandic volcano names and so on, and then somebody will speak it for you.
Nice.
And so I have a crazy plan of making a list of virus names,
Good
the
idea.
exotic ones, and then finding native speakers who would actually record this and put it on here so that we can always look up how something is
Excellent.
Nice.
That's a good idea. Let's see how they pronounce Prion.
Right.
What do you think?
Oh, yeah.
So they're going to play. Oh, there is. So how do you you have to click something.
You would search for it, and then you would see whether it's there already. So the problem is, of course, it is there. Prion pronunciations, one in English and one in French.
Cool.
Two in Spanish. But I don't have so you need to test it. I don't have my.
They are not helpful with apoptosis. They have both.
Yeah, both.
Yeah, right. Which probably means that people can use both.
Yes.
But it's going to be fun for virus names like Onyong or Chikungunya and so on, because my suspicion is that we probably all pronounce them with the wrong synthesis.
Well, we don't pronounce a lot of Robert Koch, right?
Koch, right.
Koch. How do you say that, Jens? Say it for us.
Robert Koch.
Nice.
Koch.
That's the real deal.
Koch. That's right.
No, you didn't do it right.
I should pretend to still be German, right?
Great. That's a cool one. We will use that here on TWiV. Brianne, what do you have?
I have something that I came across on Twitter, first from a graphic that I saw, and then I went back and actually read the whole article about how long vaccines last.
This is in Science magazine, too.
Yes, it's in Science. I feel like a lot of my students have asked me these questions, and there's a really nice graphic that shows the length of time that different vaccines have been shown to persist, and the pertussis vaccine stands out pretty dramatically in it.
It sure does.
And I think that it's just been really informative for me in answering a lot of questions people have asked to kind of have some of the information in one spot.
This is good.
So
it's really useful.
It raises the question about pertussis in adults, because adults usually don't get pertussis. Kids get it. So why don't we get it? Because our vaccines, faded a long time ago.
Right.
So,
is it a question of do we get it, or do we get symptoms?
Pertussis is everywhere. It's like fungus in your refrigerator.
Right. So we just may not develop the cough.
We don't.
Right. We don't develop the symptoms, but we still get infected.
Right.
Is that a boost to our already immunized self?
Yeah, sure.
So maybe that's why we don't get it.
Maybe Dickson.
Horrible though. The cough is horrible.
It is.
Tell me about
my little brother. I'm pretty sure my little brother.
I've heard of adults getting it.
It is awful. Immunosuppressed people probably.
When I was very young, when I was 8, we traveled to Italy to visit my father's family.
Yeah.
And I slept in a room with my cousin who was similar age, and she had whooping cough. And she coughed I'd never heard a cough like that. It was so scary.
Right.
I asked my mother and she told me, I said, why don't I get it? She says, well, you've been vaccinated.
There you go.
So you can sleep in the room with her.
Right.
Wow. I had the same experience with my little brother. I was home alone and taking care of him and stuff. It was horrible.
Weirdest
living crap out of me.
Wow.
Alan, what do you have?
I have a New York Times data journalism project that they did a little while ago. You plug in your hometown and the year you were born, and it tells you how much hotter your hometown is than the year you were born.
Mm-hmm.
And then it leads from there into a whole bunch of interesting factoids about other areas of the world and how climate change is affecting them, which I think does a really good job of kind of bringing home. I mean, we've talked a lot about how people don't really necessarily listen when you talk data, but they listen when you talk anecdote.
Yeah.
This takes the data and turns it into an anecdote, which I think is a very helpful approach.
Right.
Well, they don't go back to my year in Patterson, but
Really?
Wait a minute. How far back do they go?
1960.
That's not fair.
And so this is...
It doesn't even come close to my birth date.
Yeah, it's gone up slightly, but the predicted future is
Got it all the
really
way back to 1921.
not in Patterson, New Jersey.
I'd like to see what
New
New
Jersey, I
Orleans.
just put in.
New Orleans?
You're what, like 44, 45, something like that?
1953.
53. Okay.
And
Baby boomer. Yeah, I got it. Oh, our data set goes back to 1960 when you were 7. Okay.
Yeah. I'm a baby boomer. Yep.
It still gives you a good perspective on it.
Yeah, it's cool,
And
but the
It's gone
future...
up. It has gone up.
It's gone up, but the future is going to go up more.
I'm afraid
Yeah.
so.
What are we going to do? Where do we go?
Somewhere else.
Dixon, what do you have?
I'm sorry I missed the TWiV from last time, so I was going to introduce this as a pick. It's a series of photographs, obviously, taken of various places throughout the Earth from people who wanted to make an environmental statement, either positive or negative. And they're absolutely riveting. There are 50 of them, and you file through them, and you say, oh, isn't that beautiful? And the next one is a pile of junk with a little kid playing in the middle of it. And it was perfect for Earth Day, which was Monday, by the way.
This past Monday?
Yep.
Yeah.
Mm-hmm.
These are neat.
Wasn't
They are.
this week International DNA Day or something?
Yes, that's right. That's right.
Really?
Well,
Well, every day is something, isn't it?
that's true. Secretary Day, whatever
so
they
Dickson,
were.
on TWiV last week, I had an anti-pick.
Really?
And Alan wasn't there. And were you there, Brianne? You weren't there.
I was because it made me think a lot about my allergies.
So I had a regular pick, right? And my anti-pick, which is something I would never pick, is 50 tips for taking great photographs of cherry blossoms.
Oh, yes, I did. I'm sorry.
I would never pick that.
Kathy Spindler actually loved that one, actually.
By the way, my backyard is trolling you now. I almost took a picture of the cherry tree there.
Cherry trees. My pick is a book by Stanley Prusiner.
If that's how you pronounce it.
I didn't realize he had written a book about his work on prions. It's called Madness in Memory, The Discovery of Prions, a New Biological Principle of Disease. I was updating the chapter on prions for the textbook, and this was a reference in something I read, and it's wonderful because it's his telling of his experience. You know, he was trained as a neurologist, and he saw a patient with Creutzfeldt-Jakob disease early in his career, and he got interested in this. He spent some time in Papua New Guinea with Carlton Gajdusek, and he said the problem with Gajdusek was he just wanted to talk all the time.
Huh.
And so he would listen and then leave because he wouldn't stop talking. You would say a few words, and then the guy would just take off. Anyway, the reason it's really cool is that it just talks about how no one believed him early on that there was just protein. Everyone said it's got to be a virus and there must be nucleic acid. You're just not finding it. He had such trouble getting funded.
Wasn't it called Kuru to begin with?
Well, that's the disease in Papua New Guinea.
Right, but they thought that was the Kuru virus, though, right?
Well, they thought it was
Sure.
Kuru, Creutzfeldt-Jakob, et cetera. And so he had trouble getting funded. He would give talks at meetings and people would get up and say, you're crazy. You don't know what you're talking about. This word, he invented prion. They said, it's terrible that you would invent this. And he persevered and, he got it done. He made advances.
And made the Nobel Prize.
And he got a Nobel Prize, but it's true. It's just a protein.
Right.
There's no nucleic acid. But, all the prominent virologists of the time doubted him. Now, this was unfolding while I was a graduate student, and I remember thinking, this is amazing. I never doubted it. Of course, I didn't know any better, right? But I thought it was so cool.
Yeah. And frightening, too.
It's a protein. So this is his little memoir of the whole thing, which is really, it's to make a big advance, something different is hard. People don't believe you.
This is true.
Yeah.
And so from his...
May I ask why you keep it in the book?
Yeah, exactly. It's not a virus.
Oh, so that's a great question. So, and I think the reason we have it there is wrong. We didn't put it there because we thought it was a virus, but it's an unusual infectious agent. And when we first wrote the book, Lynn Enquist, one of the co-authors, said, I think we should include prions because the only people who believed Prusiner were virologists. And now reading this book, it doesn't seem to be true at all.
It's just the opposite.
So we put it in for that reason, and it's remained there. It's not a virus, but it's so darn interesting. It's actually in the chapter with viroids and satellites. But
it might be the case that the first people who finally came around to believing Prusiner were virologists.
Maybe.
Because people did eventually come around to believing him.
They did, right, when he cloned the gene and he showed that was it. But, Steve Goff told me David Baltimore said it's got to be a virus. Carlton Gajdusek said it was a slow virus. Right? That's where the slow virus came from. But that's why it's in the book and it remains. But I don't know, maybe we should take it out because it's not a virus. It's just unusual. It's really cool, though. I love teaching about it.
Oh, yeah, definitely. It's a lot of fun to think about it, but at the same time, there are also really cool viruses out there. And so if you have a book on virology, there's maybe we have an extra.
There's enough coolness in virus.
Yeah, I know.
The other thing I always notice is that it's not anywhere else.
Yeah.
Virology textbooks,
that's true.
And to some extent, microbiology textbooks are really the only place where you see them.
Yeah.
Yeah, also journals. And the Journal of General Virology still publishes all these prion articles, which always bugs me from a taxonomic point of view.
It ought to be in neurology books.
Yeah. Well.
Or biochemistry books.
Or protein biochemistry. That's right. That's right.
Yeah. Well, I don't know.
Imagine taking a course called Infectious Biochemistry. Infectious protein chemistry.
Well, I have a picture of a road sign. I don't know where it's from. I found it on the internet. It's called Prion Road. I think that's funny. I always wanted to send it to Prusiner and ask him if it predated his coining the phrase.
Whatever road
I think you should contact him and then ask him how to pronounce his name and prion for Forvo.
Correct.
Yes.
That's right. You should do it for that website. All right, that's TWiV 545. You can find all our show notes at microbe.tv/TWiV. Show notes are where we put links to some of these things we talk about in our picks of the week in case you want to check them out. Otherwise, you usually listen on your phone or tablet, right? So we would like you to subscribe to TWiV so you get every episode, and that way we know how many people are listening. If you really like what we do, consider supporting us financially. You can go to microbe.tv/contribute. You could say, give us $1 a month, and that would help us a lot. And of course, questions and comments, TWiV at microbe.tv. Our guest today, Jens Kuhn from the Integrated Research Facility. Good to have you back, Jens.
It's fun.
Are you going to any meetings this summer?
I will go probably to the ICTV meeting in Berlin to fight the newest taxonomic proposals in July. Yeah, I mean, there's also no immediate meeting that I really have to be at right now. I mean, the bigger meetings are all next year, right? I mean, ICV I think is in Korea next year. I would like to go to that one. And then ASB I'm missing, unfortunately, this year. So it's immediately no, except for the ICTV thing. And that typically taxes me enough for several months.
Yeah, arguing taxonomy is tough work. Right?
It's taxonomy.
It's taxing.
Arguing taxonomy is the most emotional thing that is possible. I mean, I really, I said this before, and I think on the taxonomy TWiV, but I have yet to understand why people can be so incredibly emotionally attached to a name. And they will fight more for the name of a virus than for their own children. Oh. So it's interesting.
Taxonomy without representation is tyranny.
Yes.
Dickson Despommier is at thelivingriver.org and parasiteswithoutborders.com. Thank you, Dickson.
You're welcome. It's good.
Brianne Barker is at Drew University on Twitter. BioProf Barker. Thanks, Brianne.
Thanks. It was great to be here. Good luck with your last week of classes.
Thank you. Alan Dove is at turbidplaque.com on Twitter. He is Alan Dove. Thank you, Alan.
Thank you. It's always a pleasure.
Alan, no tornado?
No, it missed us, I guess.
Thank goodness.
Do you ever get tornadoes there?
We get tomatoes every summer. There was a tornado that went through Springfield several years ago and took up a bunch of rooftops and did a whole bunch of damage.
They do. All right. Well, good. Yeah. We're glad that
everywhere in the United States, every county in the United States gets tornadoes, except I think there might not ever have been one in New York County.
What's New York County?
Manhattan.
That's where we are.
Right here. But I must tell you that one year, I don't know which one it was, I had to do my laundry, and I went to the laundromat because I didn't have a facility in the apartment I was living in, and a tornado came right through the middle of Fort Lee.
Really?
And it came right over to the bridge and stopped. It says, because there's never been a tornado in New York County. And it just stopped right there. And I'm not kidding.
It forgot to take the change for the toll.
It did. There were toll takers at the time, and they didn't. They got it right, but
it didn't have Easy Pass.
It did not have Easy Pass.
I'm Vincent Racaniello. You can find me at virology.ws. Thanks to ASV and ASM for their support of TWiV, and Ronald Jenkins for the music. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.